Okay, class, in this video we're going to start our first lesson of our sequence unit that we would do for the next couple of weeks. And we're going to first start off just talking about the definition of sequence. The difference between an infinite sequence and a finite sequence. It says an infinite sequence is a function whose domain is a set of positive integers. Domain is a set of positive integers. The function value terms of the sequence are represented by a sub 1, a sub 2, a sub 3, so forth, all the way to some given infinity, a sub n. Now, when you see the numbers written like this, a sub 1, that means the first term of a sequence. A sub 2, the second term of a sequence. A sub 3 is the third term, and so forth. It says sequences whose domains consist only of the first so many positive integers, n integer, are called finite sequences. And we're going to talk about the definitions of these two more in just a second after we start working them. This is what's going to make sense, okay? It says writing terms of a sequence from the general term. The general term is like the rule, okay? The rule. And you want to write the first four terms of the sequence whose general term is given. Okay? So a sub 1, I plug in 1 for n. 3 times 1 is 3 plus 4 equals 7. So a sub 1 equals 7. We want to find the second term. A sub 2. 3 times 2 plus 4. So a sub 2 equals 10. A sub 3 is 3 times 3 plus 4. So a sub 3 equals 13. A sub 4 is 3 times 4 plus 4. So a sub 4 equals 16. So those are your first four terms of that sequence. 7, 10, 13, and 16. Now let's get back to what these definitions are talking about. It says an infinite sequence is a function whose domain is a set of positive integers. Domain, positive integers. We were plugging in 1 here because it's a sub 1, a sub 2, a sub 3, and so forth. The numbers we're plugging in is 1, 2, 3, and 4. That is what it's meaning by domain is a set of positive integers. Integers there are 1, 2, 3, and 4. Because I only wanted to stop at the first 4, you could characterize this as finite because I only wanted the first 4. But if it just kept going and going and going and going and going and stop, it would be an infinite sequence. Okay? Let's look at number 2. I want to find the first 4. A sub 1 is negative 1 raised to the first over 3 times 1 minus 1. Yes, this is not as pretty as this first one. Negative 1 to the first. What if I do this? Hold on just a second. Negative 1 to the first is negative 1. 3 to the first is 3. 3 minus 1 is 2. A sub 2 is negative 1 squared. 3 to the second minus 1. Negative 1 squared is 1. 3 squared is 9. 9 minus 1 is 8. A cubed is negative 1 to the third. 3 cubed minus 1. Negative 1 cubed would be negative 1. 3 cubed is 27. Minus 1 is 26. A to the fourth. Negative 1 to the fourth. 3 to the 4 minus 1. Negative 1 to the fourth is positive 1. 3 to the fourth is 64. 64 minus 1, 63. Okay? I'm going to give you a minute to work that one before I go to that one. Try number 3. Alright, let's do this one. A to the first equals 2 times 1. 1 plus 4. 2 times 1 is 2. 1 plus 4 is 5. A to the second. 2 times 2. So 2 times 2 is 4. 2 plus 4 is 6. That gives me 2/3. A cubed. Shouldn't be saying A cubed. That's A sub 3. Let's repeat that. A sub 1, A sub 2, A sub 3. That means first term, second term, third term, not squared or cubed. Sorry about that. 2 times 3 is 6. 3 plus 4 is 7. Cannot reduce that. A sub 4. 2 times 4. 4 plus 4. 8 over 8 gives me 1. Now, we were talking about sequences. I'm going to show you something on your calculator I want you to look at. You can graph sequences in your calculator. Now, you got to put your own calculator in sequence mode. So if you go to mode, and down here where you see functions, scroll over till you see SEQ and hit enter. Second, quit. Go to Y equals, you see your things look kind of crazy. You see that little N there, you start seeing your N's, okay? We're going to type this in. 3, the variable button, plus 4. I'm going back to this first one. I'm going to hit graph. And you see it plots its points like 1, 7, 2, 10. It's graphing them, but I want you to see your table here. If you go to second table, what do you notice in your table? You see a lot of errors because it says your domain is a set of positive integers. It doesn't start at 2, it's 1, because you cannot have a sub 0 term. Your first number is a sub 1. So that's why you see a sub 1, and if you just keep going, that gives you all the values of your sequence. Okay? Let's look at the second one. Go back to this one, clear it out. I'm going to put -1 raised to the n divided by 3 raised to the n minus 1. Make sure you put that bottom in parentheses. Hit graph. Get several little blue dots close to 0. Hit second table. Once again, it doesn't start to 1. Check your answers. We got -1/2. That's 1/8. -1/26. Incorrect. Let's look at that last one. 2n divided by n plus 4. Graph. It graphed it, the relationship 1, 2/5, and so forth. 2 and 2/3. Let's look at our table. And there you see the values. So I just want to show you, you can put your calculator in sequence mode and go from there. Alright, let's look at the second thing we want to look at here. It's factorial notation. Evaluate each factorial expression. We're finally going to learn what this exclamation point means. The exclamation point means you're going to say 5 times 4 times 3 times 2 times 1. And you'll multiply that out. 5 times 4 times 3 times 2 times 1. Get 120. Now there is this button on your calculator I'm going to show you. Hit 5, go to math, and scroll over to probability. And it's number 4. Okay? 9 factorial, that would mean 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You do need to know the meaning of that, but if you just had 9 factorial, you can hit 9. And you get 362,880. So basically the factorial means you take 1 off of it to the very end. You're just taking 1 off of it to the very end until you get to 1. Subtracting 1 off. I subtracted 1 off, I got to 1. So on this one right here, I got 10 factorial over 2 factorial times 8 factorial. We'll try to do this one. I do 10 times 9 times 8. Now stop there. The reason I stop there is because on bottom I can cancel the rest of it out like this. So I'm left with 10 times 9 over 2 times 1. And that gives me 45 as my answer. We're going to do one more. We got n plus 1 factorial over n factorial. Remember, our goal is to get something canceled out when you have a numerator and denominator. Well, let's think about this. I have n plus 1. The definition of factorial is I'm going to subtract 1 off of it. So I got n plus 1. If I do n plus 1 minus 1, that's the definition. I'm taking 1 off. These cancel out, and I'm left with n factorial on it. Well, that's what's on bottom, so I cancel that out, and that is equal to n plus 1. Okay? Because the definition of factorial is you're subtracting 1 off of it. So I took this, minus 1, well, that left n. Well, that's what I needed for that to cancel out. But we're going to stop there, and we're going to do these two together tomorrow and keep going. Now I will answer more questions on number 7 if you have any.